Hello students, under the topic integration by parts. Now here we have the problem 11, 12 and 13 which involves the inverse function. So let us solve these problems one by one now. So the first problem that we will be solving is to find the integral sine inverse of x dx. Now this has to be done by using integration by parts, as we generally don't have a formula for the integration of sine inverse of x. So now we will be adopting the method of integration by parts. Already I have elaborated the method in our previous lectures, where the formula for integration by parts is integral u dv is equal to uv minus integral v du. To understand this lecture better, kindly go through the previous lectures. Now here, to integrate this, we have to make the choice of u first, after which the remaining parts we have to take it as dv. So now how to make the choice of u? We have to observe this, that is, we have to make in this order: inverse, logarithmic, algebraic, trigonometric and exponential functions. So according to this order, we have to make the choice of u. Now what appears here first? The inverse function. Do we have an inverse function in our given question? Yes, we do have it. So this inverse function has to be taken as u first. So u will be equal to sine inverse of x. And now after making the choice of u, the remaining part we have to take it as dv. So dv will be equal to, now what is remaining in this? Already sine inverse of x has been chosen as u. So dx is alone remaining in this, and so dv will be equal to dx. Now after doing so, we have to differentiate u. That is, we have to find du by dx, differentiate with respect to x, in order to find du, which we have to apply in the formula. So du by dx will be equal to the differentiation of sine inverse of x with respect to x. So what is the formula for differentiation of sine inverse of x? We do have the formula for differentiation of sine inverse of x. So that is 1 divided by square root of 1 minus x square. So this is the formula for differentiation of sine inverse of x. So from this we obtain du to be equal to, so taking this dx to the right, it becomes dx divided by square root of 1 minus x squared. So this is du that we have obtained. This is the selection of u that we have made. And dv is equal to dx, from which we will be getting v by integrating on both the sides. So integration of dv is v and the integration of dx is x. So the value of v will be equal to x. Now these three we have to substitute in the formula. Integral u dv is equal to uv minus integral v du. So let us do that now. So this is the formula that we have taken and written. Now integral u dv, what is that? That is the given question. So it is, because u is sine inverse of x and dv is dx. So this is the given question. So that we will write. So integral sine inverse of x and dx is equal to uv. So what is u? U is sine inverse of x. So let me write that first. So sine inverse of x. V is what we have obtained. V is equal to x. So multiplied with x minus integral v du. What is v? V is x. So x du is dx divided by square root of 1 minus x square. So this is v du. So now in this integral has to be evaluated separately. So what let me do? Let me mark this as some equation 1, so that I can evaluate this integral separately and later take and substitute in equation 1, which will be the required answer. So for that reason I am marking this as equation 1, and now let us evaluate this integral separately. So I have taken this and written here separately, and let us evaluate this. Now how to evaluate this integral? It has to be done by the method of substitution. So what we are going to do, we are going to put t is equal to whatever is inside the square root, that is 1 minus x square. So whatever we have here in the denominator which is inside the square root, we are taking it as t. So we are substituting this as t. So from this we have to find dt by dx, which will be equal to the differentiation of this with respect to x. The differentiation of 1, which is a constant, will be 0, and then minus differentiation of x squared is 2x. So this is what we obtain here. Now whatever is in the numerator, we have to find that. So how shall we do that? So dt will be equal to, taking this dx to the right, we will have negative 2x dx. Now in the numerator, if you observe, we have x dx. So we have x dx here. So let us take this negative 2 to the left. So it will become negative dt by this 2, it comes to the denominator. So divided by 2 is equal to x dx. So for the denominator we have made a substitution, and from which we have got a substitution for the numerator. So we have converted everything in terms of t. Okay, so x dx, which is in the numerator, is minus dt by 2, and in the denominator square root of 1 minus x squared is square root of t. So let us substitute all this now here in this integral. So this integral will be equal to integral x dx, we will write as minus dt by 2 divided by square root of 1 minus x squared is what we have taken as t. So square root of t. Now this 1 by 2, we will take it outside the denominator along with the negative sign. So minus 1 by 2 integral dt divided by square root of t. Now this can be further rewritten as negative 1 by 2 integral dt divided by the square root of t, can be written as t to the power 1 by 2. Further, we can take this to the numerator and we can write this as negative 1 by 2 integral t to the power minus 1 by 2 dt. We are going to apply here the formula integral x power n dx, for which the integration solution is x to the power n plus 1 divided by n plus 1, which we have seen in our previous video lectures. So using that, we will be integrating this. So this will be minus 1 by 2, and the integration of t power negative 1 by 2 is t to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So further let us simplify this. So this will be equal to minus 1 by 2 multiplied with t to the power minus 1 by 2 plus 1 is 1 by 2 divided by 1 by 2. So this 2 and this 2 will get cancelled. And so this will be equal to minus t to the power 1 by 2 can be written as square root of t. Further, we will substitute what is t. T is what? 1 minus x square. So when we substitute that here, we get this to be equal to minus square root of 1 minus x square. So this is the answer that we get for this part, that is integral x divided by square root of 1 minus x squared dx. We obtain it to be minus square root of 1 minus x square. Now let us take this and substitute here in this equation 1, because this is what we evaluated here, right? So at this place we have to substitute minus square root of 1 minus x squared in this equation 1. So let us see that now. So now let us substitute. Okay, so let me do it here. So integral sine inverse of x dx will be equal to, now this we can write it as x sine inverse of x minus this integral is what we have evaluated. So what we have evaluated it to be, so this is equal to negative square root of 1 minus x square. So that we have to write. So already we have a negative sign here. So that negative and this negative gets multiplied and it becomes positive. And then square root of 1 minus x square. Plus we have to add a constant of integration. So plus c. So therefore this is the answer that we obtain after integrating sine inverse of x dx. So this is the answer. Hope you have understood this problem. So in a similar way, we have to find integral cos inverse of x dx and integral tan inverse of x dx. So now let us find integral cos inverse of x dx, for which we have to make the choice of u as cos inverse of x because the inverse stands first in the selection. So u is equal to cos inverse of x, and then the remaining dx has to be chosen as dv. So dv is equal to dx. So now on differentiation of u, we get du by dx is equal to the differentiation of cos inverse of x is negative 1 by square root of 1 minus x square. Okay, and then the integral, we have to integrate on both the sides, and integral of dv is v and the integral of dx is x. So this is what we obtain after making the choice of u as cos inverse of x. Now we have to substitute this in the formula. Integral u dv is equal to uv minus integral v du. So let us do that now. So integral u dv is the question. So integral cos inverse of x dx is equal to uv. U is cos inverse of x and v is x. So we can write this as x cos inverse of x minus integral v du. V is x, du is this. So then we have a negative sign here. That negative sign gets multiplied over here and it becomes positive, divided by square root of 1 minus x squared and then dx, because when we consider only du, this dx comes to the right. So that dx we are writing here. Now we have to evaluate this integral separately and we have to substitute in this, which we have seen just now while integrating cosine inverse of x, and we evaluated integral x by square root of 1 minus x squared dx to be minus square root of 1 minus x square. So that one we will be substituting here, and so this answer will be equal to x cos inverse of x minus square root of 1 minus x squared plus c. So you have to incorporate these methods, that is the method which I have already shown you, the method of substitution. You have to use this method and we have to evaluate this. We have to show these steps while solving this problem also, and we have to take and substitute here and finalize the answer. So this is the final answer. And now here we have the 13th question, which is the integral of tan inverse of x dx. So let us solve this now. We have to make the choice of u first, which will be the inverse function. So tan inverse of x will be taken as u. To understand this better, kindly go through the previous lectures so that you will know how to choose u and dv. So the remaining we have to choose as dv. So dv will be equal to dx. And then we have to differentiate this u. So du by dx. So with respect to x we are differentiating. What is the differentiation of tan inverse of x? 1 by 1 plus x square. So that will be 1 divided by 1 plus x square is the differentiation of tan inverse of x. So from this we get du to be equal to, taking this dx to the right, we get dx divided by 1 plus x square. So let us just mark this. Then again this we have to integrate. So when you integrate dv and dx, we get the integral of dv is v and the integral of dx is x. So we have got this, and we have after making the choice of u as this, we have obtained these two. Now this has to be substituted in the formula. Integral u dv is equal to uv minus integral v du. So let us do that now. So this integral u dv is the question, because this is u and this is dv. It is the question, so we will take and write. So integral tan inverse of x dx is equal to uv. So what is u? U is tan inverse of x and v is x. So let us multiply these two. I can also write x tan inverse of x because it's in multiplication, minus integral v du. What is v? V is x, and du is dx by 1 plus x squared. So let us make that substitution here, divided by 1 plus x square. Now this integral we have to evaluate separately by using the method of substitution. So let me mark this as equation 1 and take this integral separately and evaluate it. So to evaluate this integral, we will be using the method of substitution. So what is the substitution that we will be making? T is equal to, so in the denominator we have 1 plus x square. So let us take it as t. So 1 plus x square. So from this dt by dx, we have to differentiate with respect to x. We get this to be, for differentiation of 1 is 0. Differentiation of x squared is 2x. So from this, what we get, dt is equal to, taking this dx to the right, we get 2x dx. But in the numerator, what do we have? X dx. So this x dx, we will have it as one side, and this 2, if we take it to the other side, it becomes dt by 2 is equal to x dx. So we have the substitution for both the numerator as well the denominator. In the denominator, we are substituting this 1 plus x squared as t, and through that we get the numerator x dx as dt by 2. So let us make these two substitutions in this integral now. So this integral will be equal to integral. Now this x dx can be written as dt by 2. So let us write that. So dt by 2 divided by 1 plus x squared can be written as t. So t. So further this is equal to that 1 by 2 constant. Let me take it out. So 1 by 2 integral dt by t. But what is the integration of dt by t? We know that it is log t. So that's equal to 1 by 2 logarithmic t. So what is t? T is 1 plus x squared. So let us substitute that. So we will be getting this to be equal to 1 by 2 log of t is 1 plus x squared. So this is the value of the integral x by 1 plus x squared dx. Now this we have to substitute here in this equation 1 and obtain the final answer. So let us do that now. I will just write and show here itself. So the final answer will be, after substitution of this in this place in equation 1, finally the answer will be integral tan inverse of x, okay, dx is equal to, this first we have to write x tan inverse of x, and then minus the solution of this that we have obtained here, 1 by 2 log of 1 plus x square. So 1 by 2 log of 1 plus x square, and at last we have to add a constant of integration c. So this is the answer that we obtain after the integration of tan inverse of dx. So hence we have obtained the solution for all the three. So therefore all the three solutions I have taken and written here. Integral of sine inverse of x is x sine inverse of x plus square root of 1 minus x squared plus c. Integral of cos inverse of x dx is x cos inverse of x minus square root of 1 minus x squared plus c. And finally the integral of tan inverse of x dx is x tan inverse of x minus 1 by 2 log of 1 plus x squared plus c. Hope you understand all the three. Thank you.